So here we're asked to solve for z and express our answer in exponential form. So looking at our equation, we can see we've got z to a power, and in this case it's a power of 3. So in order to solve this, essentially what we're going to need to do is change our Cartesian form here into exponential form, and that's going to make it easier for us to then undo this power of 3. So let's do that as a first step, converting this across. So if I was to draw 1 plus 1i on an Argand diagram, if this is 1 and this is 1i, it's going to sit out here. So what we can do then is figure out the length of this line, which is going to be r, and we know that it's the square root of the two components squared and added together. So 1 and 1. So that's going to be 2 inside the square root, so we're just going to have to write this as square root 2. And then the other thing we want is the argument or the angle measured from the positive real axis. So that's this angle in here. And since this is like got equal components, so 1 and 1, this is like a 45-degree triangle that's formed in here. So the angle in radians then would be equal to pi on 4. That's the same as 45 in degrees. So if we want to then write this in our exponential form, the re to the I theta, so r is square root 2, I stays the same, and our theta measured from the positive real axis is pi on 4. So that's equal to z cubed. Alright, so the next thing that I'm going to do is I'm going to rewrite this angle here with a 2 pi n. Okay. So I know that this is equal to pi on 4, and then if I write in 2 pi n here, what this is doing is adding 2 pi, which is an entire revolution of the circle, and we can do that as many times as we want. So that's what the n represents, because every time we add or even subtract 2 pi, it's just going to take us back to the same point around the circle. So this remains equal to this. Let's pop in z cubed. Alright, so the next thing I'm going to do is probably try and undo this cube. So what that means is everything here is going to get raised to the power of 1 on 3. It's just this inverted. So what I might do at the same time is square root 2, I can write that as 2 to the power of a half, okay, and then I'll leave this the same. Alright, so now we can expand this 1 on 3 in. So that means it's going to be 2 to the power of a half times a third. So 1 times 1 is 1 on the top line, and 2 times 3 leaves 6 on the bottom line. We've then got e to the power of I, and all of this stuff up here gets multiplied by the third. So I could write this as pi on 12 plus 2n pi on 3. Okay, just expanding out the bracket. Alrighty, so one last thing I might do is I can rewrite this as the kind of 6th root of 2. This is going to be like some decimal number, so there's not much you can do. I'll just leave it in exact form, and we'll leave this as it is. Cool. Alright, so now comes the part where we need to get out our answers. So n we said was the number of times you're kind of going around this circle, adding or subtracting 2 pi. So what we normally do is start by setting n to 0, okay, it's just an integer, and solving what z would be equal to in this case. So writing it out, we're going to get e to the power of I, it's going to be pi on 12 plus, we're setting n to 0, like this. So all of that is going to go to 0, so we're left with an answer of, it's going to be e to the I pi on 12. So that's one solution. So then what we do is we add 1 onto our n. So it becomes 1, and we go through the same process. Right, so this time when we substitute in n, it's going to be 1. Alright, so we've got pi on 12 plus 2 pi on 3. If I want to put these together, then I should probably get the same common denominator. So I stays out the front, so pi on 12 can stay the same, and we want a 12 down here, so we need to multiply by 4, top and bottom line, so 8 pi on 12. And then we can write it as e to the I. This is going to be a total of 9 pi over 12. And in fact, that's going to now cancel out with each other. So e to the I, if we divide top and bottom lines by 3, that would leave us with 3 pi over 4. So that would be another answer to our question. So we're going to go through this one more time, where n is equal to the next one, which is 2. And solve it. So substituting in n is 2 to this one here. So pi on 12 plus 2 by pi over 3 equals, so again there's not much we can do with this root out the front. I probably want to put these simplified, so it's pi on 12 plus, this is going to be 4 pi over 3. Again, it's probably going to be worth adding these together. So if I give them the same common denominator, so 12 is here. This one, if I want to make it a 12, I need to multiply it by 4, and that needs to happen for top and bottom lines. So I'm going to get 16 pi on 12. And then popping them together, we've got e to the, this is a total of 17 pi over 12. So that's going to be another answer. So let me highlight, we've now got our 3 roots here, or 3 solutions. Right, so I know that there should only be 3 solutions, and that's because it was z to the power of 3. If it was a different number, then we would have looked for more. The other thing I will note is that we didn't have to pick n equals 0, 1, and 2. We could have picked other integer values, but what should happen is if you pick those other integer values, you're going to be able to simplify the answer to one of these 3 roots that we found just now. So that's all there is for this question, and I'll see you in another video.